Hi, welcome to part 2 of the first lecture of week 4. We're going to be looking at section 3.4 now, and this is the section on truth functional consistency. So recall our notion, our intuitive notion of consistency. Intuitive notion of consistency. Remember what we said was that we said a set of sentences, right? So a collection of sentences are consistent if and only if each of the sentences can be true at the same time. And what we're going to do now is give a notion of consistency using our truth tables, right? So we're going to define a more intuitive one in a little bit more rigorous way by talking about truth functional consistency. So just before we do that, though, let me remind you of something that's pretty important in order to give our definition of truth functional consistency. And this is the tool of sets that we already talked about. So let me just remind you of that. So when we have a set is a collection of things. And so we have, let's see. Well, in this case, it could be just about anything, right? So you could have a set of the cars that are owned by the parents of all of the students in Philosophy 12. That could be a set. So each of the cars would be a member of the collection. The collection, isn't specifically anywhere. It's just it's an abstract thing. And in the same way as we can talk about collections of cars, for example, we can also talk about collections of sentences, so sets of sentences. So sentences can be what are called members of sets. And we denote sets with the following symbol. And if you remember our use mention discussion, so if we're just mentioning this symbol, we need to put it within quotes. So we say that this left brace and the right brace are the symbols to denote sets. And if we're saying that sentences can be members of sets, then we're saying things like A, B, E are sentences that are members of the set. And here I'm going to be using it, right? So here I'm saying what that set is. So we want to say A, B, E. Okay. Well, one of the things you're noticing is that I'm being extremely careful in the fact that I'm mentioning these sentences, not using them. But this is sometimes going to be pretty painstaking. So by now we should hopefully have gotten a good enough grasp of the difference between use and mention and that ambiguity that we shouldn't be confused if we just write this sentence with without the quotes around the sentence letters, because that'll be a pain in the butt if we have to write that all the time. So we're just going to say by convention we drop the quote marks so that we just have A, B, E. Okay, and these commas aren't actually not members of the set. What the commas just say is when the first member, so to speak, is over. So it's saying it's distinguishing the different members of the actual set. But the comma is not a member of the set. Same thing over here, right? I mean, the quotes aren't members of the set. It's the actual sentence that is a member of the set. Here we're strictly speaking using the sentence A, but by convention we're just going to drop the quote mark. So whenever you see these sets, you can always think of us just mentioning the sentence, not actually using the sentence in there. Okay, and there's actually one other symbol which I don't think we'll make use of very much, but when there's a set like this, there's nothing in it. So we say that, we'll put some quote marks around that. We say is empty. In other words, we call it the empty set. Is the empty set. And there's also a different kind of notation as well, where you have a circle with a strike through it. That's also sometimes used to denote the empty set. Okay, so now with sets as a tool, as a formal apparatus, or sorry, as a formal tool, we can use that now to define truth functional consistency. So we say that a set of sentences is truth functionally consistent if and only if. And for what it's worth, whenever I say a set of sentences, I mean a set of sentences of SL. So maybe if I was being a little bit more careful, I would say a set of sentences of SL is truth functionally consistent. Sometimes we'll just say a set of sentences, where that just abbreviates of SL. Okay, so a set of sentences of SL is truth functionally consistent if and only if there's at least a one truth value assignment where all the members of the set are true. So this is remember how we said that it's possible for them to be true at the same time? Now we're saying what exactly that means. So a set of sentences of SL is truth functionally consistent if and only if there is at least one truth value assignment on which all the members of the set are true. So let's go over an example of this. Suppose we have the sentence, well, let's stick with the one that we had before. So if we look above here, the question, so these were two sentences we considered, A or not B, and not A and B. Is there a truth value assignment on which, at least one truth value assignment, on which both of these sentences are true? And the answer is yes. Just consider the first one. Here, the sentence is true, and here the sentence is true on this truth value assignment. Hence, the set of sentences that would contain this sentence and then this sentence would be a consistent set. Let's consider another example of a set that won't be consistent. Let's have A, and then we'll have, let's make it really simple, A and not A. So consider this set. Well, if we look at the truth table for this, remember there's going to be two possible truth value assignments. And what we want is, in the first case we have the sentence A, and then we also have the sentence not A. So under A, well, we just know that that's true on this truth value assignment, and we know that not A is false on this truth value assignment, right? Because negation just flips a truth value. So that means on this truth value assignment, these two sentences, the sentence A and then the sentence not A, do not agree, right? So they're not both true in this case. So already we know that these two sentences are not logically, truth functionally equivalent. But what we're asking about here is whether or not this set is a consistent set. So we're just looking at a scenario in which both of them could be true at the same time, where what we mean by at the same time is that they can be true, that they both can be true on the same truth value assignment. So let's consider the second truth value assignment where we have A is assigned false. Well, here A is false, and for our second sentence, not A turns out to be true. So again, they're assigned different truth values on this truth value assignment. So there's no truth value assignment on which both of them are true, which means that they fail to be this set fails to be truth functionally consistent. Why? Because the second part of this biconditional is not met. We said that there has to be at least one truth value assignment on which all the members of the set are true, and that's not the case here. There's no truth value assignment on which all of the members of the set are true. Hence, since this side of the biconditional fails, we know the other side of the biconditional has to fail as well. So we say that it's not the case that that this set of sentences is truth functionally consistent. In other words, we say that a sentence is truth functionally inconsistent if and only if it is not consistent. So we can write that too. A set of sentences of SL is truth functionally inconsistent if and only if it is not consistent. Okay, but this might not always be so obvious, right? So let's think about a little bit more of a different example. So consider the set of sentences where we have G, right arrow, this is the material conditional, H, and then we have not H. Okay, so the question is this set of sentences truth functionally consistent? Well, let's make our truth table as we usually do. So we have our atomic sentences G and H, and then we have the sentence G. We have our sentence if G then H. Oh. And then we have our sentence not H. Okay, and remember, our test here is going to be looking to find whether or not there's a truth value assignment on which each of these sentences turns out to be true. And hopefully by now you've mastered how to make these truth tables really quick. I'm going to go a little bit quicker here on the assumption that you guys have started to master this a little bit. So we know that G is going to be true in this scenario, and if G, then H is going to also be true here because both the antecedent and the consequent are true, and not H is going to be false. Okay, here again G is going to be true. So notice actually in this first truth value assignment where we made G true and H true, not H, which is a member of this set, turned out to be false. So here's a truth value assignment, and it's not the case that each of the sentences are true on this. So we need to keep going. Okay, here we have it that the material conditional is false because G is true and H is false on this truth value assignment. And we can assign true to not H. Okay, here G is false, right? Because on this truth value assignment we're giving G the truth value false. This material conditional turns out to be true, right? Because as soon as the antecedent is false, you know the whole thing is going to be false right away. And on this truth value assignment, G is taken to be false. I'll remove that up there for you. And not H is false, because on this truth value assignment, it's true. So again, on this truth value assignment, we have it that not each of the sentences are true at the same time, right? So here we have both G is false and not H is false. Okay, so we need to at least find one truth value assignment where all these sentences can be true at the same time, and so far we haven't met this. So this is our sort of last hope, last chance to see, or the last place where each of them could be true for this truth value assignment. So G is taken to be false, then the material conditional turns out to be true here, and not H, turns out to be true here. But notice that G is false. So on this truth value assignment, it's still not the case that each of the sentences can be true at the same time. And all of these possibilities exhaust all of the possible ways of assigning truth values. So this set turns out to be an inconsistent set. Why? Well, there is no truth value assignment such that each of the sentences are true, right? In other words, on every truth value assignment, at least one of those sentences turns out to be false. So let me just write that out for you, actually. We say, so is an inconsistent set of sentences of SL because there is no truth value assignment on which all sentences are true. Okay, so now we've gone over some examples and you have a notion of truth functional consistency as well. If you have any difficulties in understanding this, just make some comments on the video and we'll see you guys in class.